So if we want to integrate using partial fractions, so we need to note that in what is it? The exponent, the degree of exponent must be greater in the denominator now. I can say it must be lesser, must have a lesser or smaller degree of exponent in the numerator. So in applying partial fractions, the degree of exp, exp is greater in the denominator. In the denominator. So that's when we'll be applying integration into partial fractions. So we dissolve the fractions into partially so into partial fractions. So in this case, we have algebra as a moment, we have division of functions. As long as we have divisions of algebraic functions, therefore we can think of log division or partial fractions. So in a case, let's say for an example, I'll just put a function there, let's say f of x can be linear, or yeah, let's say maybe it's a linear function to give for an example. So let's say for an example, it's divided by ax. Then let's say in bracket we have bx. Let me just put plus or minus d, plus or minus d. So when we want to dissolve into partial fractions, so if an example, let's say if we're supposed to integrate, we have to, what we're going to do, we're going to dissolve this into partial fractions let me start with the part where if we didn't have factors in the denominator. So we must resolve the denominator to be in factors. Then if we have the denominator in factors, therefore we can split the first factor to have, let's say for example, a. It will be divided by capital A. So the first factor, ax there, will be divided by a. And the second factor, which is bx minus d, plus or minus d, it will be dividing the capital B, the partial fractions. It is sharing, or is divided by bx plus or minus d. Then, if let's say for example, maybe we might have had a linear function. Now, if let's say we have let's say maybe a bracket, nth bracket, let me say bx plus c. Let's say for an example, it's to the power of 3. Say it's to the power of 3. Okay, the 3 is not that visible. Let's say it's to the power of 3. The exponent is 3 in there. So when we dissolve into partial fraction, if let's say we have now, this is the third bracket. So we need to expand the first fraction will be a divided by the first exponent to the power of 1. So they have bx plus c. So we start from the lowest exponent up until the highest power that we given, the highest factor then. So and then we'll move on and say we have b. The second fraction will be bx plus c, all in all to the power of 2. As much as we saw that it was to the power of 3, we need to even have the third fraction, which is going to be c divided by bx plus or minus c, all in all to the power of 3. So start from the least bracket to the highest power, which is 3. Which is 3. Okay, I hope it is clear then. So let's say for an example, we had maybe, let me just use an example. Let's say for example, let me just put ax. Let's say we have a factor that maybe it is not a linear factor. Let's say it's x squared plus or minus, let's say plus or minus b. Plus or minus b. So we found out we couldn't factorize into utilizing what do you call, utilizing, let's say, a whole number, shell when it comes to this one. So if you couldn't factorize this into let's say linear factor, what we're going to do, we do the same thing when we split. When we split the first one factor as it's a linear and it's just one term as it is, so it's ax. So it will be divided by a. But when it comes to this one that we couldn't factorize the square, or let's say the difference or sum of, let's say, squares. But if let's say it's a square, normally it happens when if it's a square, but difference between two squares we can manage. So let's say if it was a sum of two squares. So we know that we are going to split it in this way. We're going to say bx. We must have a linear numerator, a linear function in the numerator. So we have bx plus c. Therefore, all divided by that quadratic function in the denominator plus b. If we couldn't manage to factorize this factor, so when we split into, when we dissolve into partial fractions, the first term, first factor is dividing a. Then the second factor, which is x squared plus b, will be dividing a linear, let's say, factor, for example, bx plus c. So that's how we'll be utilizing a partial fraction. So how you resolve into partial fractions. So I want to take an example where we have to utilize the partial fraction. The exponent is greater than the denominator. Okay, maybe we can start with the easier one. For an example, if let's say we have number one, we have, let's say, integral of 11x plus 9 all divided by x squared minus 9 dx. So we do our utilize our inspection skills. First check, we have in the numerator of a linear function, in the denominator of a quadratic function. Therefore, we see that the exponent is greater than the denominator. And number two, even if you wanted to try and let's say, for example, can I derivate the denominator and get the numerator? So we can't get that numerator because the derivative of this constant was supposed to be 0. If let's say maybe we had 11x, we could say maybe ln of the denominator. But knowing that if let's say we have algebraic functions, we can now utilize partial fractions. Therefore, we'll state that dissolving into partial fractions. Dissolving into partial fractions. Dissolving into partial fractions. We have 11x plus 9. So we need to make sure we factorize the denominator. That's the first thing. So when we factorize, the denominator is a difference of two squares, right? So we have x, it's x plus 3, then an x minus 3. That is the factorization of difference between two squares. Now, the second part, we have to dissolve into partial fractions. So we'll state that this is equals to. Therefore, the first term will say that the first fraction will be a divided by the first factor, which is x plus 3. So we'll have x plus 3. The second term, the plus, therefore we'll have v all divided by the second factor now, which is x minus 3. Therefore, why are we utilizing partial fractions? Is because we need to calculate the value of a and b. So when you have done that, we are going to multiply out throughout the right hand side and the left hand side by this factor, by x squared minus 9, or by x plus 3 times x minus 3. So what we're going to do in this, let me do this, in this factor must be multiplied by the denominator. So I don't think there will be space there. So we'll be multiplying by x. It's x plus 3, right? So we don't have space there. And then we multiply by x minus 3. So that's what we'll be doing, x minus 3. So even a will be multiplying it by x plus 3, x minus 3. So it's because of spacing, I'll just explain law. So if let's say we see that x plus 3 will divide x plus 3 and x minus 3 divide x minus 3, we know that we'll be left with 11x plus 9 equals 2. So in the right hand side, we're multiplying now the fraction by x plus 3, x minus 3. So we know that x plus 3 will be divided, there will be left with 8 times x minus 3. So same thing, this fraction must be multiplied by the denominator of the left hand side. So multiply x minus 3 is divided, therefore we have b into x plus 3. So that's what we have done. Now the second part is to make sure that we are going to deduce equations. We're going to deduce equations that we must have coefficient of x in the left hand side must be equals to coefficient of x in the right hand side. So which means on the right hand side we must make sure we have at least x plus 9 or x plus a constant to say. The coefficient of the x and plus the constant. So but in the meantime, let us multiply out. We have ax multiplied by 3 multiplied by a, we have negative 3a. Therefore, b multiplied by x, it is bx. Then b times 3, so I have 3b. So as I said, we must have in the right hand side the term that consists of x and the term that consists of the constant. So we need to group it in this way as 11 plus 9, 11x plus 9. So I hope you see that these two terms, they have a common factor, which is x, isn't it? So we're going to make sure that we add the two terms a plus b, and please factor out common factor x. Then same thing, now in fact with the constant, you just say plus, group them together. You can have minus 3a plus 3b. So these two terms, they are just constant, they don't have x. We say they are constant, they don't have function x. So we have grouped the terms that consist of x and the terms that are constants. Group them together. Now the second part, so now we can deduce equations. So we'll say that the coefficient of x in the left hand side is 11, isn't it? Then in the right hand side, the coefficient of x is a plus, there is a plus b. So we state that this is equation, that is equation 1. Now going to the constants in the right hand side, the constant is 9. On the right hand side, we have what? Minus 3, a plus 3b. So therefore, we have equation 2. So from there, we can utilize the elimination method, or we can utilize simultaneous equation. So normally I will say maybe in this part, just recall how to utilize elimination method. So if we want to utilize elimination method, we know that at least we must try and eliminate one variable, for an example. So how can we manage to eliminate either a or eliminate b? So we must make sure that first equation must be multiplied by 3. I hope you see. So that when we add the two equations, we can eliminate a, for an example. So what we're going to do, we're going to say that if we multiply equation 1 by 3, what are we going to get? So multiply 11 by 3, we do, what do we have? 33. And multiply a by 3, 3a, and we'll have plus 3, 3b. Then in the second step now, when we have that, we're going to say that we're going to add equation 1 plus equation 2. So add equation 1 plus equation 2. So let us add 33 plus 9. 33 plus 9 is 40. So we have 42 equals 2. So I hope you see 3a plus minus 3a is 0. It's out. So 3b plus 3b, we have 6b. From there, we can now solve for b. So what is 42 divided by 6? It's 7. So the value of b, it is equals to 7. Now, if we want to find a, so we substitute in either of the equations that we have there. We can substitute in the first one that we derived, or this one, or this third one. So let's take the simplest one. So we're going to say sub the b into you want 2 or 1. We can utilize the equation 1. So we know that we're going to have 11 equals 2. Therefore, a plus b we have calculated, which is 7. Therefore, we can find now our variable a there. So it's going to be subtracting. So the value is, so we have 4. So 11 minus 7, it is 4. 11 minus 7, it is 4. From there, we are done now determining the variable a and b. So what we're going to do, we're going to state that if we have dissolved 11x plus 9 over x squared minus 9 dx into partial fraction, it is equals to, when we want to integrate. So we're going to integrate variable a, which is said it's 4, all divided by x plus 3 dx. Therefore, the other fraction, it is b all divided by x minus 3 dx. So we have dissolving this fraction into let's say fraction into partial fractions. So therefore, when we want to integrate, it will be equals to. So I hope you recall. You can try and utilize inspection method, isn't it? The rule that I can put here that you must recall, I hope you recall that, for an example, if let's say you had this, you had a derivative in the numerator, all divided by the function. So we stated that the integral of that will be ln of the base, isn't it? Because we have the function in the denominator and the derivative in the numerator. And we know derivative of ln f of x is 1 over f of x times f prime of x. So f prime of x all divided by. So we know that when you derivate x plus 3, we're going to get 1. We're going to get 1. So just drawing this down, I know because I'm studying a chapter, I hope people, you know what is happening. X plus 3 dx plus a factor. You can factor out a constant. So I want you to see that in the numerator you have what? Your derivative. Derivative of x, it is 1. So you factor out the constant. So it was not necessary what I just did there to draw it below. So at least now we know that, oh, integral of 1 over x plus 3, it is 4 ln of the base of the denominator to say. Ln of the denominator. So it's 4 ln x plus 3. The second one will be 7 ln x minus 3. Therefore, plus the constant. Plus the constant. So that is integral of 11x plus 9, all divided by x squared minus 9. So from there you can get your full marks. But I just want to play around this the last step there. But it's not necessary. We have integrated, but I want you to recall the rules in case when you're going to utilize them in another unit. So for an example, let's say you have, when we're having that, I hope you still recall exponential, not exponential, logarithmic laws. That if, let's say, the log is multiplied by any coefficient, you can raise what is inside the log to be to the power of 4, isn't it? That is log rules. I hope you still recall. You can still drop down the exponent. You can raise log to the what is inside the log to the power of 4. And same thing, if the one we have 7 then the coefficient of the natural logarithmic can be raised to x minus 3 plus the constant. So there we're just utilizing the log rules. I said it's not necessary, but just feel the need of explaining this so that if you utilize log rules, especially in N5, you have to remember that. Another log rule that you could remember, if let's say you have the logs of similar base and the coefficient is 1, and you have addition. So when you addition of logs of similar bases, you are going to multiply what is inside the logs. So you can have ln now of x plus 4 all in all to the power of 4 multiplied by x minus 3 all in all to the power of 3. Close shop, therefore plus c. So that is the log rule. If the basis of the logs are the same and the coefficients of the logs are the same in addition, we can multiply or we can have product of what is inside the logs. I hope you still recall that one. Yes. Oh, sorry, it is 7. Q, it is 7. Where did I get 3? So it is to the power of 7. So that is the log rule that I wanted, the two rules that I wanted you to recall. But it's not necessary up until this point. You are done integrating. So when you're in the test, don't waste time. As long as everything is standard, you have answered the question. Leave it there. And move on to the second question. So we have 6 minus 2x all divided by 3x squared minus 2x, therefore dx. So we need to integrate. We need to integrate. So integral of the following will be equals to, so we need to utilize partial fractions. Why? We see that the denominator is having a greater degree of exponent, and then in the numerator is just a linear function. So what we're going to do, we'll state that dissolving into partial fractions, dissolving into partial fractions. Therefore, the solution will be equals to, so we'll have negative 62x all divided by. So let us try and factorize there. How can we factorize that? Take out the common factor of x, isn't it? So x into, we're left with 3, x minus 2. So we factorize it utilizing factoring method. And from there it equals to, so the first term will be the first fraction, variable a will be divided by the first factor, which is x. Then we'll have b all divided by 3, x minus 2. So we have what we call, we have dissolved into partial fractions. And the next part, we need to multiply by this denominator of the original fraction. So multiply by that denominator throughout the equation on the left and the right hand side. So when we multiply, always will be left with 6 minus 2x. Multiplying the first term here, we'll be dividing x, will be left with a times 3x minus 2 plus with b, these will be dividing when we multiply here, we'll be left with x. So we'll be multiplying with x. Okay. Now we can multiply out and have negative 6 minus 2x. So we need to group accordingly. So we multiply out here, we'll have 3, let me say 3ax. Though is 3xa. So I just want to have x as a last factor in this first term. Then a times negative 2 is negative 2a. Then we'll have b. We'll have bx. So the second part is to make sure that we have, at least this is to the power of 1. It's x to the power of 1. So we must group the terms which consist of x and the constant on the left and on the right hand side. So let me start with negative 2x. Therefore, I have positive 6 there. I just rearrange the terms. I've rearranged. On the right hand side, we see that term 3a and that they have common factor x there. So we factor x out. But while we're grouping them, so 3a plus b, factor out x. Therefore, the constant is just minus 2a. So the constant is just minus 2a. Then from there we can state that the coefficient of x in the right hand side, in the left hand side to say, it is minus 2. We have minus 2. On the right hand side, the coefficient of x is 3a plus b. We'll state that that is equation 1. Now, for the constants, the right hand side is minus 6. It is equals to the constant in the right hand side, which is minus 2a. So we have equation 2. You have equation 2. So now we can with the easier one, we can determine the value of a. Can determine the value of a. So value of a is equals to, from equation 2. From equation 2, we can solve for a. A is equals to negative. So it's negative 3, isn't it? So divide by negative 2 on both sides. Therefore, a is equals to negative 3. And we can substitute a into equation 1. So when we substitute a into equation 1 is minus 2 into a is minus 3, therefore plus b. Isn't it? So what is the answer of b? So this I think is minus 9, right? take to the other side, it will be positive. So it will be, is it not 7? So 3 times minus 3 is minus 3. Take minus 3 to the other side is positive 9 plus negative 2, so which is positive 7. Okay. So from there, we can now state that if we have dissolved minus 6 minus 2x over 3x squared minus 2x into partial fraction, it will be equals to, we need to integrate a over x, and we said a is minus 3, all divided by x, dx. Therefore, plus integral of b is 7 over 3x minus 2, isn't it, dx. I hope it's clear. Though I said this is not necessary, but because this is a lesson, please note that the constant, you can factor it out and have your 1 over x then, dx. And same thing, plus 7 integral of 1 over 3x minus 2. Then all multiplied by dx. So we inspect the first one. I hope you see already straightforward. 1 over ln x. It's 1 over x is what? It is ln x. So 1 over x, the integral of 1 over x is ln x. Because we know that the derivative of x in the numerator is 1. So ln of the denominator, Therefore, plus. Do the inspection again. At least we have a linear. We have a constant in the numerator, and the denominator is a linear function. So inspect derivative of 3x minus 2. It was supposed to be what? 3, isn't it? So we are missing what? A constant what? 3. So when we're done, we must make sure we state that it's 7 ln of the denominator. We must always divide by the derivative of what? Of the function inside there, or by the constant that which is missing. Because initially we're multiplying when we're derivating, but now we divide. So we had a missing constant, which is 3. Therefore, plus c plus 3. And when you derivate, you must still get the top part we were integrating. You must still get the top part we were integrating. So let's say, for example, we have to integrate the following. Let's say we have 2x squared minus 5x plus 6, all divided by, where am I copying, x minus 2, all in all to the power of 3, dx. So I have 2x squared minus 5x plus 6, all divided by a bracket of x minus 2, which is to the power of 3. So, do the inspection again. I hope we see already the exponent will be greater in the denominator after multiplying out, because you'll have x cubed. So not to waste time with algebraic functions dividing each other. So the exponent is greater in the denominator. So what we're going to do, we'll do the same thing. At least this one is factorized. It's factorized. So dissolving into partial fractions. So dissolving into partial fractions. So therefore, we'll have 2x squared minus 5x plus 6, all divided by what? By x minus 2, all in all to the power of 3. That's too much. So, as much as we see that we have a factor to the third bracket, which is x minus 2. So we'll do the justice of saying that the first fraction will be divided by the linear function by x minus 2, all in all to the power 1. Or if you want, you can start by the highest exponent going to the least. So it doesn't matter how you start. You can start with the highest power going to the least exponent. Therefore, we'll say plus b all divided by now x minus 2 all in all to the power of 2. We must express that until the highest power x minus 3 to the power of 3. Well, it's x minus 2. X minus 2 to the power of 3. So that's how we'll be dissolving into partial fractions if the bracket is to the third power. Now what we're going to do the same thing. We multiply out by factor by this denominator here throughout the equation. So we know when we multiply in this first in the right left hand side, we'll be left with 2x squared minus 5x plus 6. On the right hand side, I hope you see it will be equals to a. So if this is to the power of 1, it eliminates 1 there, so we'll be having a times x minus 2 to the power of 2. And when we multiply here, we'll have plus b into. If it's this to the power of 2, it will be dividing to the power of 3. Now we're left with x minus 2. The third term, when we multiply by the nth bracket, even there, there's an nth bracket, so we're left with c. So nth bracket divides the nth bracket. You're left with plus c. So the step that follows is to multiply out the right hand side, so we can group the coefficients of x squared and the coefficients of, or the term that consists of x, the terms of consisting of x squared. So I have 2x squared minus 5x plus 6. It will be equals to. So we know how to multiply a square bracket. So we'll have 2 to the x raised to the power of 2 times a. So we'll have ax. We have 2 times minus 2 times x. That is minus 4. X is in it. Times a. Therefore, negative 2 to the power of 2, it will be 4 times a. We'll have 4a. Then with this bracket, we'll have b times x. It will be bx. Then b times minus 2 minus 2b plus the constant. Amen. So now the second part will have 2x squared minus 5x plus 6. So let us group the terms that consist of x squared and terms which consist of x and the constants. So if the x squared is just one term, isn't it? With the x squared is just one term. Then the other ones which consist of x is this one and this one. So group them together and take out the common factor. So hence I will say plus minus 4a plus b. Factor out x. So we group them together. And the constants, we group them together. Let me do this. So it's 4a minus 2b plus c. Close short. So it's 4a minus 2b plus c. Then the last step here is to deduce the equations. Deduce the equations. So we're going to say that the coefficient of x in the left hand side, which is 2, will be equal to the coefficient of x in the right hand side, which is a. So this is easier. A is equals to 2. Now with the coefficients of x, now in the right hand side we have minus 5, and the left hand side we have minus 4. for A plus B. It gives us an equation 1. That one we cannot say it's an equation, it's just a solution. Then followed by the constant. So we'll have 6, it will be equals to. So it will be equals to the constant in the right hand side, which is 4A minus 2B plus C. So we have equation 2. So what we're going to do, we're going to state that we want to solve for B. It's easier in that way when you solve for B. So it's easier when you solve for B. Of this. So we are going to state that we are going to substitute A into 1, isn't it? So therefore into 1 we'll say 5 is equals to minus 4. A is 2, therefore plus B. And then B will yield a value which is equals to 8. So it's 3, isn't it? So we have negative 8. Take negative 8 to the right hand side. It will be positive, left hand side, it will be positive 8. So 8 plus minus 5. That is 3. So B is equals to 3. All right. Okay. From there, we have to calculate the value of C. The value of C will state that we are going to utilize equation 6. So we need to substitute A and B into equation 2. So in equation 2, 6 is equals to 4. Then we said A is 2 minus B. B it is 3. Therefore plus the constant C. Plus C there, variable C to say not a constant. So when we simplify, it's 8 minus 6, which is 2. Take 2 to the other side, it will be minus, subtracting from 6. So we have 4, isn't it? So this gives us 2. Take 2 to the other side, subtract from 6, we have 4. So C is equals to 4. So we'll state that where's the original function? That 2x squared minus 5x plus 6 all divided by x minus 2 all to the power of 3 dx. Into partial fraction, it is equals to an integral of A we said is 2 all divided by x minus 2 dx. Therefore plus integral B we said is equals to 3 over x minus 2 all in all to the power of 2 dx. The last term will be plus integral of, then we have C, which is 4 all divided by bracket x minus 2 all in all to the power of 3. Therefore dx. So we have to integrate, look into the first one. The first one, we know that when we derivate x minus 2, we're going to get what? 1. So derivative of x minus 2 is 1. So it's multiplied by that constant. So we know it's ln of the base multiplied by the constant. So ln of x minus 2. Now let us inspect the second one. 3 over x minus 2 to the power of 2. I hope you see this is a square bracket. And we have a constant in the numerator. We have to try and figure out. So what did we derivate? We have 1 over x minus 2 to the power of 2. can try and look into the formula sheet. So sometimes you start with the formula sheet if your brain is stuck not to give you the integrals. But not to waste time. So this is what I'm going to do. I hope you recall that if, let's say, I see the square bracket, let me try and take it to the numerator because I know ln of the denominator won't work. I'll have negative 2 dx. I'll do the same thing with the other one because it must be 4x minus 3 to the power of 3 dx. So thank you, x minus 2. So, not to waste time, I wanted you to utilize product of functions. So, when you see Marshall brackets, first of all, inspect what is in the bracket. When you derivate what is inside, will you get what is outside? When you derivate x minus 2, will you get what is on the side? Yes, I can say yes. Because this is a constant, I can factor it out, isn't it? So derivative of x minus 2, it's 1, isn't it? So it's 1. So factor out that 3, you'll know that, oh, the bracket is multiplied by 1. So which means it will be the rule of chains of functions. So the rules of chains of functions, where you're having f prime of x multiplied by 1, so x in bracket to the power of n dx. So that rule comes back. It doesn't run away. So we think of it in that way because you know when I see what is inside the bracket, it can give me the derivative of what is outside, which is 1. Yes, it's negative 3. The exponent is negative 3. This one. So I hope we see that at least with this one, we can say we still have our 2 ln x minus 2. Therefore, plus, according to the chains of functions, when we integrate, we are going to add 1 and divide by that exponent where we have added 1. So our constant doesn't run away, it's 3. Therefore, we add 1. So minus 2 plus 1 is negative 1, isn't it? And therefore, we have plus the last term. It was 4. 4. Same thing. The derivative of x minus 2 gives us 1. So we still multiply by that constant. So therefore, x minus 2. Let us add 1 into minus 3. So we'll have minus 2. Therefore, plus the constant. So please forgive me not to divide by the exponent. We always have to divide by the exponent. So we add 1, divide by that exponent. So add 1 and divide by that exponent. Minus 2. So this one, I will say there's a need for you to simplify, most especially the negative exponents. They don't look nice when they're negative exponents. So you can have, with this one, you can have ln of x minus 2 to the power of 2. The other one, this one will be negative 3. If you want to make the negative 1 bracket positive, you have to take it where? It's the denominator, isn't it? So you'll have x minus 2. Therefore, the exponent is positive now. The bracket 1 is positive. So we're using exponential loss. We need to make the exponent of this x minus 2 bracket positive, take it to the denominator. But in the meantime, divide 4 by negative 2. So we have negative 2 is in it. Then all divided by the bracket, we need to make it a positive bracket. So it's going to be to the power of positive 2. So plus c plus the constant. Okay, I hope that is clear. So here was just simplification. So please, when you solve rules, other rules won't run away, even if you're in partial or in long division. They follow you. I hope you'll agree with me that when you want to derivate this, you'll have to take it to the numerator. It will be minus 1. Then derivate, it will be minus 1 multiplied there. It will be positive. You subtract 1, it will be negative 2. And derivate what is inside, which is 1. So you integrate and derivate we must still get this, the functions that were given before. So it's number 4 in the textbook, but here I'll say it was 3, then I'll say this is 4. So let's say we're given x cubed minus 2, all divided by x to the power of 4 minus 1 dx. So we need to integrate the following. Take it again. So the exercise that we were doing yesterday. So let's say we're given the following x cubed minus 2 all divided by x to the power 4 minus 1. Already we see that the exponent is greater than the denominator and the numerator is lesser. But we even inspect, can we not maybe use ln of the base? But we know that derivative of x squared was supposed to be x cubed, but derivative of constant was supposed to give us 0. So here we still have 2 terms. So which means this is not the derivative of the denominator. We have to utilize partial fractions. So therefore, dissolving into partial fractions, the dissolving into partial fractions. So therefore, we'll state that we will have x cubed minus 2 all divided by. Let us try and factorize that, the denominator. So not to waste time, obviously we'll have to have 3 terms, 3 factors to say. We have to have 3 factors. We have to have 3 factors. But not to waste time, obviously is difference. It's not really difference of 2 squares, but yeah, it's difference of 2 squares. Because if you express this as a square and 1 as a square, I hope you see what is happening. It's difference of 2 squares. So when you factorize, you're going to have x squared minus or plus 1. The other one is x squared minus 1, isn't it? When you factorize this. So it's difference of 2 squares, we have that. But again, after factorizing, we still have difference of 2 squares. X squared minus 1. So we're going to have x plus 1 and x minus 1. So that's what we're supposed to do. So we'll have to have x squared plus 1 and x squared minus 1, which is x squared plus or minus 1. There you can express it as x plus or minus 1. That's what we have. You need to factorize fully. Don't just factorize and leave it as an x squared minus 1. We can still factorize x squared minus 1. So I hope you see if you multiply out, you'll still have the same answer. Okay, I hope you're sorted. So this is basics of factorization. So into partial fractions, we say that is equals to the first term, it will be a. Now here's the catch. If you want to start with the other factors, you can start with the other factors. But this one, we cannot factorize it further. It's a difference between 2 squares. You can try and factorize using whole numbers. It won't work out. Don't even think of x plus 1 and x minus 1. Or x plus. Because I know through experience, I once saw this. Sorry to reuse some problem. Because I know some, they start doing this. And they say it's x plus 1 and x plus 1. And which is a lie. When you multiply out these, I hope you see you'll have x squared. The middle term, let me do this, it's x plus x, therefore plus 1. And it gives you 2x. So which means you didn't factorize the x squared plus 1. So these are just basics and just reiterating, don't mix difference between 2 squares and sum between 2 squares. So it will be math error when you say you're factorizing x squared plus 1. So if we can't factorize it further, therefore we conclude it's going to be ax plus b, isn't it? It must be dividing a linear, let's say, function, because we couldn't factorize it further. So we'll have x squared plus 1, which is a quadratic expression. Therefore, plus the second term, it will be c. Let's utilize c. We can utilize x plus 1. Just allow me to write the other term here below, which is going to be, let's utilize d, all divided by x minus 1. X minus 1. So what we're going to do here, so we're going to multiply out. So we're going to multiply out by this denominator throughout. But we know in the right hand side, it will always execute minus 2. And then it will be equals to. So take this denominator, multiply by it, and ax plus b. The x squared will be eliminated. Please switch on the summary. So I hope you see this x plus 1 times x minus 1 is a difference between two squares. So it will be multiplying ax plus b, because after dividing x squared plus 1, not to have a lot of terms, we'll be multiplying by this. And this is the difference between two squares, which is x squared minus 1. Or it's x plus 1 times x minus 1. It's multiplying ax plus b. Then with the one for c is the one that you cannot skip, which is going to be c. Then x plus 1 will be eliminating the x plus 1. So we're left with c, which is multiplied by x squared plus 1 times x minus 1. Therefore, the one for d is going to be plus this multiplied by x squared plus 1. The x minus 1 is eliminated. We're left with x plus 1. That is an exam type problem. So in that case, we have to multiply out. In the right hand side, we still have our x cubed minus 2. It is equals to. So let's multiply out ax times x squared. It's ax to the power of 3. And ax times minus 1, negative ax. Then b times x squared. So we have bx squared and b times minus 1 minus b. Silence. And therefore, the other one now, we have now two squares. I'm saying two brackets to say. So what we're going to do, we're going to say x squared times x, it's x cubed, isn't it? Therefore multiply by c. So we have cx cubed. Then x squared times minus 1, it's x squared times c. We have cx squared. We need space here. We're not done now. We're going to 1 times x. Oh, it was negative, no? So we said this times that and then that. So this is negative cx squared. Right, so let's go to the 1 times x. It's x, then times c. We have plus c. Put it here. So carrying over, we are done multiplying by 1 times x. It's x, then times c. Then 1 times 1, it's cx, right? And this is saying multiply by c. Therefore, it's 1 times x plus x times c. It is cx. Then 1 times minus 1, negative 1 times c, negative c. Need to move on to the other one here, d. So x squared times x, it's x cubed times d, dx cubed. Then x squared times 1, it is x squared, and times d, we have dx squared. Then 1 times x, x times d, we have dx. And therefore 1 times 1, we have 1 times d, so plus d. So the step that we require now, we need to group the coefficients of the cubes and the terms which consist of the squares, the terms that consist of the axis and the constants. So we are going to say x cubed of the right hand side minus 2 is equals to. So let's start with the ones which consist of the cubes. So I hope it is A, it is C, and D, isn't it? So it's C, D, and it's A, C, and D. So B doesn't have square here. So we are grouping them together, A plus C and D to the power of 3, isn't it? To the power of 3, isn't it? Then let's group the one with squares. B minus C there, and D. So we group them together. So we have B plus, let's set minus C, and plus D. It's x squared. So we need to move to the ones with coefficients of x, coefficients of x. So it's negative A and positive C, right? And positive D, the ones with coefficients of x. So say plus, so it says minus A plus C plus D. Then x, that is the coefficient. Then the constant, we group them together, constants. So let us check the ones that we didn't highlight is minus B. And then let's follow negative C. And that we didn't highlight, therefore plus D. So those are the constants there. Now when we are done grouping the coefficient of x cubed, the coefficients of x squared, the coefficients of x and the constant, then we can equate with the right hand side. In the right hand side, we have the cubed, isn't it? So its coefficient is what? Coefficient of x cubed, it's 1. Therefore equals to the right hand side coefficient of x cubed, which is A plus C plus D. Give us equation 1. Now we're going to the coefficients of x squared. In the right hand side, we have x squared. No, so which means it's what is 0, isn't it? So I have 0 there. Therefore, in the right hand side, coefficient of x is B minus C plus D, isn't it? So we have equation 2. Now, in the coefficient of x in the left hand side is negative. Which one? The coefficient of x, right? X squared. Coefficient of x squared, it is B minus C plus D. Yeah. So we're going to the coefficient of x now. In the right hand side, we don't have them, so it's 0. It will be equals to. Then coefficient of x is negative A plus C Therefore, plus D. That is equation 3. We check now the coefficients, or now we're going to the constants. So on the right hand side, the constant is minus 2. Then, it's left hand side. Therefore, right hand side, we have minus B, minus C, plus D. So therefore, we have equation 4. So let's hope with multiplication we didn't make a mistake, because with one mistake after multiplying, it affects your simplification. So, but always make sure you rectify from the multiplication, you restart again after having the equations. And please be fast and multiply. It says x cubed, negative x, bx squared, the negative b, come to this x cubed, cx cubed. Then negative cx squared, x times c cx, negative c, it is still fine, x cubed dx. Then we have x dx squared, 1 dx plus d. So it's fine there. And then when you take out the coefficients, you make sure you have a, you have c, you have d. Plus, now for the x squared is b, n minus c, and d. For the x's, it is minus a plus c plus d. Therefore, constants will be minus b minus c plus d. So which means it's fine, as long as you verify that you still have everything correctly, so that it doesn't affect your equation. Then from there, because we have 4 systems of linear equations, we can utilize determinants if you want, or matrices if you want. Yeah, you can utilize determinants. But not to waste time, but with elimination method, it's going to be easier. Elimination method. So with elimination method, if you have eliminated, let's say 2 equations or 1, please make sure when you continue, don't reuse it when you eliminate. So look at this. I'm going to start with the first 2. I see we can eliminate certain variables here. So I'm going to say, let's see which one we can utilize. So I can say, for an example, let's try and end equation 2. I want to see what equation we're getting. So when you add the 2, we're going to say 1 plus 0, which is 1. Then a doesn't have like term here, it will be still what? A, isn't it? Therefore, b doesn't have like term, we still have what? B. So therefore, we'll say c minus c, isn't it? So it's out. And therefore, d plus d, it gives us what? 2d. So we can say maybe we might have created an equation 5 here. Equation 5. Equation 5. Or if we are smart, let me see which one can we eliminate. At least if we can eliminate 2 terms. So, but let's try and utilize the last 2. The last 2. If let's say we say, for an example, let's say 3 plus 4. What do we get? So we're going to say C, 0 plus minus 2 to say, still minus 2. Then minus A doesn't have like term here, it is still what? Minus A. Then B in this equation doesn't have like term, it's still minus B, isn't it? And therefore, C eliminates C. I hope you see. Therefore, D plus D, it is 2D. Then let's say we have created equation 6 from adding the equations. So please don't be tempted and you want to go and take this and add it to any of the equations there. So they are out there now. We are left with these 2 equations after we've eliminated. We can try and do the same elimination method and say, let us try equation 5 plus 6, isn't it? So if you say 5 plus 6, what do we get? So it's going to be 1 minus 2. It's minus 1. Therefore, A minus A, it's out 0. Then B minus B, It's out, then 2d plus 2d. So we have 4d. Therefore, at least now we can solve for d, isn't it? So therefore, d is equals to negative 1 over 4. We still have a long way. We have how many variables to calculate now? 3 left. So you have to go to your initial equations 1, 2, 3, 4. Try and eliminate other variables and be left with 1. And be left with 1. It's an exam time problem. Exam time. So in our equation 1, 2, 3, 4, let us try and eliminate now and see which variable we can leave out at the end. So if you want, you can mix, let's say for example, 1 and 4 and 2 and 3. It doesn't matter which one you mix, but as long as you don't recycle one equation over and over. So we start afresh. Let's say we want to add 1 plus equation 3. So I'm doing them odd and even equations. So we're in 1 and 3. So we're going to say, okay, we do something like this, that we are utilizing this equation now. So that is clear. It's clear what we're doing. So we're utilizing equation 1 and equation 3. Please pay attention to them. So we're going to say 1 plus 0, which is 1, equals 2. So a plus minus a is 0, right? Then we'll have c plus c. We have 2c, right? And then we have d plus d, which is 2d. I think we can stop there, not continue further. This can help us to determine c, isn't it? We have d already. So we'll state that now. Therefore, if we substitute d, therefore 1 will be equals to 2c, therefore plus d we said is negative 1 over 4. From there, can I skip the step? No, let me not skip it. So 2c is equals to, so we have 2 times negative 1/4, which is negative half, right? So negative half, take it to the other side. It will be 3 over 2, add it to 1. So I have 3 over 2. So I have 3 over 2. So divide 3 over 2 by 2 is going to be 3 over 4. So 3 over 2 divided by 2 is 3 over 4. I hope that is clear. So what we utilized now, it was the odd equations 1 and 3. Already we had D, so we just substituted and got C. So we have to do the same thing. Or let's see if we can manage to calculate A. Then going and eliminate the equations. I think we can utilize equation 1, right? To get A. Can utilize equation 1 to get A because it consists of C and D. We calculate. So we'll now utilize equation 1. So utilizing equation 1, we're going to say equation 1 is 1 equals to A plus C. C is 3 over 4. And then D, it is negative 1 over 4 after utilizing equation 1. Therefore, A will be equals to, I'm skipping steps here. So 3 over 4 plus negative 1 over 4, which is 2 over 4, therefore which is half. Take half to the other side. You are subtracting from 1. You are getting 1 over 2. So I hope we are together. Utilize a calculator. Get the answer. The brain will be stuck. 3 over 4 plus negative 1 over 4. It is half. Take half to the other side is negative half. Subtract from 1, which is positive half. So I think here we can utilize another equation if we want. to determine b, isn't it? We can either use equation 2 or 4. We must still get the same answer. So let us utilize equation 2. So utilizing equation 2, it is 0 equals to b minus c. C, it is 3 over 4. Therefore, equation 2. Therefore, plus d. D, it is equals to 1 over 4, negative 1 over 4. So let us add negative 3 over 4 minus 1 over 4, which is negative 4 over 4, which is 1, isn't it? So it's negative 1. Take negative 1 to the other side. We're going to get positive 1. Negative 3 over 4 minus 1 over 4. So it's negative 1. Take 1 to the other side. It will be positive 1. I hope that was clear. How many pages? 2, 3. So it's an exam type question. So now we're done calculating the variables, we can go and resubstitute in the original one. Which one can I move? So in a blank page, so I'm going to state that integral of x cubed minus 2 all divided by x to the power 4 minus 1 dx into partial fractions. Integral, we are going to have a, it's half, right? Half x b plus b, right? All divided by x squared plus 1 dx. So we have that. And then the other one was c, integral of, I'm looking into c, c was 3 over 4, all divided by x plus 1, therefore dx. The last one plus integral, now it was d. No, I think, where's d? Or d is negative 1 over 4, all divided by, we utilize x minus 1 as a factor, dx. X minus 1. So, let us inspect this denominator and numerator. So when we derivate the denominator, do we get the numerator? But really, suppose give us 2x plus 0. And this one is a half and a 1. So you go and check your formula sheet. Does it resemble something? You can think of inverse trigonometric functions for tan, but for tan you must have a constant in the numerator. It's out. You think of the other ones, if you have ln of something, it's out. You could even want to take it to partial fractions, but it will take you back here because this is a denominator of a quadratic expression. When you utilize the ax plus b, it still takes you back here. So if you apply partials, it will still take you back here, isn't it? So that's where now you can state that the following, I can express it as half x all divided by x squared plus 1 dx. Remember, this denominator is shared by both numerators. So plus integral of 1 over x squared plus 1 dx. So that one we have split it into two fractions because the highest exp we have that. The highest EXP, we have that. So therefore, from that, the other one we can integrate, isn't it? We can integrate, isn't it? We know that derivative of x plus 1 is it's 1. So here we just have a constant, we can factor it out. So we can say plus 3 over 4, ln of the base, x plus 1. Okay, we're integrating. We have integrated. Therefore, there's the last term, same thing we inspect, at least we know derivative of that, it gives us a constant, it's a linear function. So it's a ln of the denominator. So we still have a minus 1 over 4, ln of the base, x minus 1. So once we can add the constant in the midterm, though we're not done integrating. The first term, we have split into two fractions. So we move further. So according to when we utilize inspection, I hope you see the derivative of x squared plus 1 must give us what? Derivative of x squared plus 1 must give us 2x, isn't it? But here we have 1 over 2, or we just have x. Factor out the 1 over 2. So it means there's a factor which is missing, which is 2. I hope you see that. So when we're done, you need to divide by that factor. So we know this ln of the base will give us the derivative. The only factor which is missing is 2. So please make sure, let's take out that factor out and have that x and that. But when we integrate this ln of the base x squared plus 1, we said there's a factor which is missing, which is 2. Because when we derivate this, we're supposed to have 2x. So there was a 2 which is missing. So forget about the half there. So this is for Nesamara. So when I say inspect, I'm saying look into this. Derivative of this gives us what? 2x. There's a 2 which is missing. So you must divide by that factor which is missing at the end. When you are integrating, then as you say, ln of the base. So we divided by that 2. It was still multiplied by the k, the constant. Therefore, plus. Not to waste time, what is 1 over x squared plus 1? It's what? I hope you know that when you derivate the denominator, we can't get the numerator. So we know that this takes us to the inverse trigonometric functions, tan, which is tan. Because derivative of arctan x is 1 over x squared plus 1, or 1 plus x squared. So I hope you see. So we have x squared plus a squared. So that is the inverse. It's arctan. It's arctan x. So it's x over 1. So that is arctan x. And then we're done integrating the rest to rewrite our functions accordingly. 3 over 4 ln x plus 1. And therefore minus 1 over 4 ln x minus 1 plus the constant. This you'll make it 1 over 4. It will be 1 over 4. If you want, you can raise the x squared plus 1 to the power of 1 over 4. And the other one, x plus 1 to 3 over 4. And use the rules. But when you're there, you are done. This one.